Hello everyone! Today I would like to tell you about such an unusual metal as boron. In the periodic table, boron is located on the very top of the group 3, right above aluminum. The history of using boron dates back from ancient China, where people used a naturally occurring compound borax, which is sodium tetraborate. Later on, Europeans began to use it too, and they extracted pure boron from it. It is obtained through decomposition of boron volatile compounds in hydrogen current. Now you can see so-called crystallic boron, which has a very high melting point and low chemical activity, which is also the hardest element to break. Besides crystalline form, boron can also be amorphous, that is, have a different inner structure. Such different forms of the same element are called allotropes. There have been more than 10 allotropes of boron. From a chemical point of view, boron is poorly studied, because it is very difficult to obtain its pure form. However, I'll try to show you something interesting. One would think that since boron is placed between metals and non-metals, it should have properties of both classes. To start with, I heated up small bits of crystallic boron with a gas burner and watched the process run. Basically, nothing special happened, just as was expected. Boron doesn't oxidize well in the air. In order to make boron lose its mere free electrons, I set it on fire along with a powerful oxidizer, potassium chloride. In the end, I made boron lose its electrons. After that, it partly turned onto boron oxide, which melted right away. Now you have seen metallic properties of boron, or rather, how it loses electrons. Besides, boron's properties can also be similar to those of his fellow elements. In the other words, the other metals. It can be proved if crystalline boron is added to molten alloy of sodium hydroxide, or in other words, to alkali. It can be well observed how this semi-metal immediately starts reacting with the alkali, forming hydrogen bubbles, which burn well when set on fire. In order to demonstrate other properties of this metal, I mixed boron with one of the most active metals, with lithium. After that, I set this mixture on fire. It can be well observed that boron reacts with metals too. It starts stealing electrons from the defenseless lithium, forming a mixture of different boron and lithium compounds. However, these reactions don't have many applications. Boron compounds reactions and their end products are way more interesting. For instance, there is such a naturally occurring compound as boric acid, which is most commonly used as an insecticide and which gives fire a beautiful green color. It can also react with ammonia at high pressure and temperature. This reaction will form boron nitride, an extremely interesting compound. Such light and heat-resistant crucibles weigh very little and can withstand high temperatures well. However, that's not all. If to mix another boron compound, boron oxide, with its carbide, you'll get a very solid compound, boron carbide. It exists in different forms. It can be a plate and powder. By the way, such plates scratch glass well, and its solidity can be compared to that of tungsten carbide, according to Rockwell's scale. Boron carbide powder fits well for abrasive machining, such as polishing different surfaces, where plates can be used as composite armor. It took effort to make such an improvised armor. I glued pieces of boron carbide on a sheet of paper with the help of silicone. After that, I went to a shooting range. My friends were happy to fire at such a DIY target. Even a 9mm caliber gun easily pierced holes in such a plate. We also took a rifle, just to be on the safe side. Probably my carbide plate was not of a high quality, because boron carbide plates are very solid and fragile, so they quickly cracked. By the way, such type of armors are made from a few layers of thick boron carbide plates and Kevlar. At the same time, the energy coming from bullets is also absorbed by other materials, whereas boron carbide breaks down bullets. All of that was nothing compared to real use of boron nowadays. The thing is that naturally occurring boron consists of two non-radioactive isotopes. One of them is boron-10. It can perfectly catch thermal neutrons without radiating hardcore gamma rays. This property of boron is used practically at every nuclear power plant. A mixture of boric acid and other boron-10 compounds is used to make control rods that change the speed of the chain reaction running in the reactor, and also to suddenly stop it. For instance, such rods can be made from steel with pure boron, or boron carbide, for instance. It's noteworthy that on its own boric acid not only can regulate uranium core decay, but being a great fire retardant, it can also put out a fire. Many matrices are soaked in boric acid in order for them accidentally not to be set on fire. Boron compounds are also commonly used in washing. For instance, sodium perborate, which when heated to 60 degrees Celsius forms hydrogen peroxide, which is able to whiten clothes in water. And it is added to a lot of laundry powders. And also every chemist, whether he wanted this or not, has dealt with boron, not pure boron through, but rather borosilicate glass that most laboratory glassware are made from. When sodium in glass is substituted with boron, the obtained material comes out very resistant to temperature changes, and such a glass has a very low expansion coefficient, which is sometimes written on laboratory glassware. Such glassware perfectly withstands sudden temperature changes and can easily be taken off a red hot stove and be put on a piece of ice. Such glassware won't even crack. It is also noteworthy that boron compounds are essential to survival and disease resistance of lots of plants. To sum up, we can say that boron is a hardly noticeable but extremely important element, without which to stop a chain reaction will be very difficult. For the provided boron carbide for the experiments, I'll thank the company Stanford Advanced Materials. I put a link to their site in the video description. If you would like to support the continuous production of science videos like this one, please support channel on Patreon, link in the video description. Please like this video and subscribe to my channel to see many more new and interesting